All right, we will be doing section 510, factoring by grouping today. Please put this in your notes. It is. The first slide that we're going to is a review. I'm just going to briefly talk about it. You do not have to recopy it. You do have this in your notes. It looks like this, right? To factor completely, we've talked about this before. First thing you always look for is the GCF, all right? It does not matter whether you have binomials, trinomials, or polynomials. You still look for the GCF. Some clues for you. Binomials, we want difference of two squares. It looks like this, and we factor it in this form. If it's a trinomial, we learned about this yesterday, the perfect square trinomial is in factored form here, or factor add, which we learned about last week, or factor add. All those things we've learned we can't forget about because they're coming and they're going to stay here now for the rest of the year. This is our new topic, grouping by factoring. So we're going to be looking for perfect square trinomials, differences of two squares, and GCFs. Okay? Here we go. So we're going to factor completely. When I look at this, first thing I ask you is, how many terms do I have? How many terms are up here? Anybody remember? I see some hands. No one sure? Yes? Two terms. Here's one term. Here's another term. Now, when I look at those two terms, I have factors in there. What factor is the same in both of them? Sam. Very nice. So I'm going to pull out my y minus z. And when I pull out my y minus z, what am I left with? Yes. X minus 3. Nice job. Completely factored. Not too bad? Can we go on? Not yet. Okay. You ready? All you do is pull out. This is a GCF. I'll give you a printout of this. If you don't want to write it all down. All right, here we go. Next one. Here it is. Next question. I have 5 times b minus 4 plus 3a times 4 minus b. Again, I have two terms. Here they are. But I have a little bit of an issue. Do I have anything that matches up perfectly? No, I don't. So, this is where this idea comes in. Okay, I have a minus b, and if I want to change positions using the commutative property, I can move them around, but I also want to change the signs. So I factor out a -1, right? So when I look at this one, I like this first one right here. So I'm going to keep this one the same. I'm going to say 5 times b minus 4. I like that one. I want to move this one around. I'm going to copy down the plus. I'm going to copy the 3a. I'm going to put parentheses around it. And then I have to factor out a -1. When I pull the -1 out, positive 4 becomes -4. Minus b becomes plus b. That looks better, doesn't it? Now we keep going. I'm going to recopy again, 5 times the quantity, b minus 4, plus, I'm going to do my multiplication, -3a, and now I'm going to use the commutative property to move them around. Not too bad? Good. What do I do next? Sam? Very nice. So b minus 4, you're left over with 5 plus -3a. I'm not wild about double signs. Josie. Very nice. The addition minus, or the addition and the negative turns into a subtraction. And now I have it completely factored. That is pretty cool. It's not too bad. This is grouping. It works really nice. We have 4 terms. Okay, our next problem is x squared minus 2x plus xy minus 2y. Notice this time there's no parentheses. So you have to make a choice of how you're going to group it. We can group, and I would like you to write that down. You can group it 2 by 2, 3 by 1, or 1 by 3. Those are our choices. Okay. All right. Now, when I look at these choices, these 2 choices are probably going to be our perfect square trinomials or differences of 2 squares. Okay, a combination. This one is going to be looking for GCFs. Okay, so I'm initially going to try this 2 by 2. All right, now this time I'm going to try it 2 by 2. So I'm going to group them in the order that they have here, and I'm going to think x squared minus 2x plus xy minus 2y. This may or may not work, but we have to try. So when I look at my first term, is there a GCF? X. Nice job. So I'm left with x times the quantity, x minus 2, plus, Dylan, GCF on the second one. This one. Sweet. And you pull out the y and you're left with? Nice job. Now, when you look at this, does this help us? Huge help. Megan, what is the GCF between those 2? X minus 2. And when I pull out the x minus 2, what am I left with, John? X plus y. Nice job. So this is now completely factored. All right, when I look at this one, I have 4 terms. We have to look at it a couple ways. First thing I always check is 2 by 2. And I look at it in the order I have. I look 2 by 2 here. And when I look at these 2, is there a GCF I can pull out of each of those? That's always my first check. So the first one, someone said I can take x to the second out. And when I pull x to the second out, I'm left with 3x minus 1. Nice job. On this one, and this is where you want to be very careful. Look at it. This is 3x minus 1. Do you want to pull out a positive 3 or a negative 3? It's got to be one or the other. A negative 3, I hear everyone say. So I'm going to pull out a negative 3. When I pull out a negative 3 here, what do I multiply negative 3 by to get negative 9x? 3x. What do I multiply a negative 3 by to get a plus 3? Look at how nice that worked out. Now, Cheyenne, GCF? 3x minus 1. Nice job. And when I pull out the 3x minus 1, I'm left with x squared minus 3. So I place the x squared minus 3 in here, and I end up with this factor. Now, there's one thing you have to double check. Look at this one. This is a perfect square. Is that a perfect square? No. So we're done. We're done. when we're looking at question number 5, we had a discussion, we looked at this, and we noticed we had a Z here, and then we had X's here. That's giving us a clue that we're going to do this as a grouping of 1 by 3. So I'm going to say 9Z squared. And remember, we want to be looking for a difference of 2 squares. This is a perfect square. Difference means subtract. So when I subtract and I put my parentheses here, what's going to happen to these 3? Are the signs going to stay the same, or are they going to have to change? Very good, they have to change. So this was a minus x squared. It becomes a x squared. This is a minus 4x, so it changes to a, very good, plus 4x. And then this is changing to a plus 4. Nice. Now what we're hoping when we do this is when we look here, we're hoping for a perfect square trinomial. Is it a perfect square trinomial? Yes, it is. So now I have 9z squared minus my parentheses squared. I have my x squared here, so I take the square root of it and I get x. I have my 4 here. I take the square root of 4 and I get 2. How do I decide what sign I put in here, in the middle of the x and the 2? Sarah? Very good. They're both adding, so I have to have an addition sign. All right, now take a look. Anybody recognize this? Yes. Ladies and gentlemen, I have 2 terms. The first term is a perfect square. The second is a perfect square. This is a difference of 2 squares. And we know when we do differences of 2 squares, we have a plus, minus. And how do I find the square root of 9z squared? Mitch? 3z. So I put 3z in both of them. And then I go over to this last term. I have the quantity x plus 2, the quantity squared. How do I take the square root of that? Yes? X plus 2, x plus 2. And you'll notice in both of these, I made sure I put my parentheses in. We're close to done here. We have to get rid of the parentheses, so I have 3z plus x plus 2 times the quantity 3z minus x minus 2, because we have to distribute that negative 1 to both terms. When I do that, I have my final factored form right there. All right, when we're looking at this, and we notice that 2 by 2 is probably not our best option, because I have m's and n's. These 2 are squared, and then I have an m here. That gives me a clue that my m squared, my 6m, and my 9 would be my 3 grouping, and then I'd tag along the 9n squared. So there's my 3 by 1 grouping. You're using the commutative property to move those items around. Now when I'm looking at this, I have a perfect square trinomial, and I have a perfect square. So when I when I factor, I'm going to have a perfect square trinomial factoring here. Would anybody like to tell me what this is? Matt, what do you think? M squared plus 6m plus 9, m plus 3, quantity squared, and then I just dropped down the minus and the 9n squared. Now I have a difference of 2 squares, and I'd like you to finish.